Okay, the last question is pretty involved. We might do it in two parts. We'll see how it goes. We start off. We've got FA and FB. These two lines here are tangents to the circle. We're given some information about FD and CBB being parallel. FD, these two lines are parallel. Let's see, did I mark them in? I didn't mark them in, but FD and BC are parallel. And CAF is equal to X. Okay. Well, we're going to write down 5 other angles that equal X. Oh, and that's a little bit tricky. The first one I just put up there, that's equal to X because this is a tangent to this chord. And the tan chord theorem says that B4 is equal to A2, which is X. And A1 must equal X because these two signs are exactly the same, so angles opposite equal sides must be equal. So we've got A1 as X. Well, let's try the next one. B3 must be X because that's a tangent. That's an angle between a tangent and the chord BC. So that has to be the same. A1 and B3 must be the same. They're both X. Now we knew that BC and FD are parallel. I should have put in parallel marks there. That makes F1 equal to X. F1 equals X because of alternate angles. Now the next question, it took me a while to see it. I don't know why. It's a thing we're supposed to learn in grade 7 or 8 or something. These two angles here are called the exterior angle of triangle DBF here. Well, these two X's, these two angles have to add up to 2X. That means angle D must be X because of the exterior angle of triangle BDF. X and X has to add up to these two exterior angles. So there's your 5 things that equal X. So now, how do you know BEF is a cyclic quad? Well, BEF, these two X's I see are exactly the same. They open up to the same chord. Well, the converse of angles in the same segment mean that ABF must be a cyclic quad because F1 equals A1 equals X. So that one's all done. Let's take a look at the next one. AF equals BD. Well, AF equals BF. Those are tangents from the same point up there. We know that's true. We know that DB equals BF. DB equals BF because these two angles are the same, sides opposite equal angles. Well, if AF equals BF and DB equals BF, then AF must equal BD. And I see sometimes people don't put anything here, but that's called a transitive property, that those two things must be equal. If they're both equal to BF, then AF must equal this BD, and that's what we're supposed to prove. Now the last ratio, let's take a look at this last ratio. Okay, we're going to prove that AF to FB is equal to DE to AE. Well, to do that, I found quite an easy way to do it. Now, I won't go through in the video the other way is using similarity, and it's about 8 steps. But we know BF is equal to AF because we've proven that before. But DE equals AE. Let's take a look at this. DE equals AE because A1 and D are both equal to X. Sides opposite equal angles, right? And this equal isosceles triangle here. DE must equal AE. Well, if that's true, then AF over BF, if they're both equal, is a ratio of 1. And so is DE over AE. They both have a ratio of 1. And that's it. That's all there is to it. Now, the textbook thing is about 7 or 8 steps. And you can take a look at it in Google Slides. But I like this way because simpler is better. There's a thing called Occam's razor. And in science, a simpler explanation is the best one. The fewer number of variables and things to think about. So there you go.